Welcome to the hydraulics lesson. This lesson will discuss the components and controls of the hydraulic system. There are three independent hydraulic systems on the aircraft designated left, right, and center. The left hydraulic system powers some flight controls, the left thrust reverser, and a number of spoilers on the right and left wing. The right hydraulic system powers some flight controls, the right engine thrust reverser, and a number of spoilers on the right and left wing. The center hydraulic system powers some flight controls, landing gear actuation, leading edge slats, nose gear steering, right and left wing spoilers, and trailing edge flaps. The flight control system components are distributed so that any one hydraulic system can provide adequate airplane controllability. The controls for the hydraulic system are located on the overhead panel. Review the hydraulic panel before pressing the Continue button to resume the lesson. Hydraulic system indications are displayed on both the status synoptic and the hydraulic synoptic. Review the indications on both the status and hydraulic synoptic displays before pressing the Continue button to resume the lesson. Hydraulic fluid is supplied to each hydraulic pump from the associated system reservoir. The reservoirs are pressurized using pump outlet pressure. Both reservoir quantity and system pressure are displayed on the hydraulic synoptic and the status synoptic. The hydraulic system pressure is displayed in pounds per square inch. The hydraulic system reservoir quantity is displayed as a percentage of normal service level, or 1.00. Reservoir quantity indications will also display LO for low quantity when fluid levels are below 0.4, OF for reservoir overfilled when fluid levels are greater than 1.2, and RF for requires refill when fluid levels are between 0.4 to 0.75. The engine-driven pumps, or EDPs, are the primary hydraulic pumps for the left and right hydraulic systems. Each EDP is driven by its respective N2 rotor. The engine-driven pumps are controlled using the left and right engine primary pump switches on the hydraulic panel. When the left or right engine primary pump switches are off, the engine-driven pump is powered off and depressurized. When the left or right engine primary pump switches are selected on, the engine-driven pump pressurizes the related left or right hydraulic system whenever the engine is running. If engine RPM drops below predetermined sub-idle values, the EDP will automatically depressurize. Depressurizing the pump at low N2 values helps maintain the engine's windmill start capability. System logic will re-engage the EDP at certain airspeed and configuration settings to provide hydraulic pressure for landing operations. The primary pump switches include a fault light within the switch to provide warning of abnormal conditions. A fault light illuminates for low primary pump pressure, excessive primary pump fluid temperature, or the pump is selected off. The left and right hydraulic systems each have a demand pump. The demand pumps are electric motor-driven pumps, or EMPs. The pumps provide supplementary hydraulic power for periods of high system demand. The demand pumps also provide a backup hydraulic power source for the engine-driven primary pumps. The pumps are controlled by the electric demand left and right pump selectors. When the selectors are in the off position, the pumps are not powered. The auto position is the normal operating position. In the auto position, the left and right demand pumps operate under the following conditions. If system pressure is low, for 3 minutes immediately after both engines have been started on the ground, from the time takeoff thrust is set until flaps are retracted, during the final phases of descent and landing from gear down or RA less than 1,000 feet to ground speed less than 40 knots, or during thrust reverser operation. If the electric demand pump selectors are moved to the on position, the demand pumps will run continuously. A fault light is located below each demand pump switch to provide warning of abnormal conditions. The fault light illuminates for low demand pump pressure, excessive demand pump fluid temperature, or the demand pump is selected off. 2 electric motor-driven pumps, or EMPs, provide hydraulic power sources for the center hydraulic system. The electric motor-driven pumps are controlled using the C1 and C2 electric pump selectors on the hydraulic panel. When the selectors are in the off position, the pumps are not powered. The auto position is the normal operating position. With both selectors in auto, one pump operates as a primary pump, while the other operates as a demand pump. The Flight Management Computer, or FMC, determines which pump operates as the primary or demand pump based on the calendar day. The C1 pump operates as the primary pump on odd calendar days, and the C2 pump operates as the primary pump on even calendar days. The primary pump operates continuously after the second engine is started. The demand pump operates if system pressure is low, for 3 minutes immediately after both engines have been started, when takeoff thrust is set until radio altitude exceeds 2,000 feet, flaps or slats are in motion, or during descent when the gear lever is down and radio altitude is less than 2,000 feet until ground speed is less than 60 knots. When a C1 or C2 electric pump selector is placed to the on position, the associated pump runs continuously. A fault light is located below each center electric pump switch to provide warning of abnormal conditions. The fault lights illuminate for low primary pump output pressure, excessive primary pump fluid temperature, or the pump is selected off. The ram air turbine, or RAT, is a small air-driven turbine that directly drives an electrical generator and a hydraulic pump. The RAT is capable of providing electrical and hydraulic power throughout the flight envelope. When deployed, the RAT provides hydraulic power to the primary flight control components connected to the center hydraulic system. The RAT can be deployed by pushing the ram air turbine switch located on the hydraulic panel. Press the ram air turbine switch. After the ram air turbine switch is pressed, the ram air turbine unlocked light illuminates to indicate the RAT is not in the stowed position. The ram air turbine pressure light will illuminate once the RAT is deployed and the center system primary flight control hydraulic pressure is greater than 3,000 psi. In flight, the RAT will deploy automatically if both engines have failed, all three hydraulic system pressures are low, loss of all electrical power to the captain and first officer's flight instruments, loss of all four EMPs and faults in the flight control system occur on approach, or loss of all four EMPs and an engine fails on takeoff or landing. The center hydraulic system has isolation functionality to ensure key systems remain operational in the event of a hydraulic leak. The hydraulic isolation system ensures the flight crew can lower the landing gear and that nose wheel steering is operational. The isolation function uses a nose gear isolation valve, a reserve steering isolation valve, an alternate extend isolation valve, and a reservoir standpipe. The nose gear isolation valve isolates nose gear operation and nose wheel steering. The reserve steering isolation valve isolates the flow of fluid between the C1 and C2 pumps in order to help preserve nose wheel steering. The alternate extend isolation valve isolates the landing gear alternate extension system from the reservoir. All isolation valves operate automatically and cannot be controlled by the crew. The left and right hydraulic systems each have an engine-driven pump hydraulic supply shutoff valve, or SOV. The SOVs are positioned between the reservoir and the engine-driven pump, or EDP. Each SOV is controlled by its respective engine fire switch. When an engine fire switch is pulled out, the SOV closes and the EDP is depressurized. There are certain airplane failure modes which require one or more of the demand pumps to load shed. Load shedding will occur when the electrical system is unable to provide sufficient power to other systems. If a demand pump is shed, load shed appears on the hydraulic synoptic next to the corresponding demand pump symbol.